Section 3.2, Factor by Grouping. In this section, we will factor out a common binomial factor and factor a four-term polynomial by grouping. In the examples below, the binomials in parentheses are called binomial factors. Notice if you look at the first term, you have 2 times a plus b. So that in that term, a plus b is a binomial factor. In the next term, it's made up of the factors 3, the factor x, the factor y, and the factor x minus y. So you notice x minus y is a binomial factor in that term. So the distributive property is used to factor a common binomial factor from an expression. Okay? So this expression that's on the right here, whoops. Get my felt tip pen going. This expression here that's on the right, I've rewritten it on the next slide just to try to explain it a little better. So notice we have x times y minus 3 as one of our terms, and 4 times y minus 3. And you can see that the greatest common factor is going to be the binomial y minus 3. So just like we did in the first section in 3.1, we're going to factor out the y minus 3. So we're going to write the GCF, which is a binomial in this case, y minus 3, and then in order to figure out what our missing factor is, we divide each of our terms by y minus 3. Well, in this case, y minus 3 divided by itself is 1, and 1 times x is x, plus y minus 3 divided by itself is 1, and 1 times 4 is 4. So we've factored the y minus 3 out of the expression that we started with. And when we factored it, we get y minus 3 multiplied by x plus 4, or, because of the commutative property, it would be also alright to say x plus 4 multiplied by y minus 3. It is important that you have parentheses around both of those binomials, or it will not say the same thing. So let's factor out the common binomial factor in these two examples. Our first term is a multiplied by x plus y plus 4 multiplied by x plus y. So you can see that our common binomial factor is x plus y. We're going to pull it out of there, x plus y. So we know the factor x plus y times some other factor equaled this whole thing to begin with. So I'm going to divide by x plus y, divide by x plus y to figure out what goes in parentheses. X plus y, that will cancel or equal 1. A times 1 is a, plus x plus y divided by x plus y is 1, and 1 times 4 is 4. So x plus y multiplied by a plus 4, or a plus 4 multiplied by x plus y. B, our first term, x times b plus 2 minus y times b plus 2. Our greatest common factor, the binomial b plus 2, I'm going to pull it out. And then I'm dividing by b plus 2, dividing by b plus 2 to find my missing factor, x minus y. Or, because of the commutative property, it would be alright to write x minus y multiplied by b plus 2. I hope you're catching on. Alright, we have a couple more of these. So we have the term c multiplied by x minus 6 minus 7 times x minus 6. We're going to factor out or pull out the common factor x minus 6. I will divide each of the terms by what I am pulling out, undoing multiplication. I'm undoing multiplication, undoing that distributive property. To find my missing factor, c, this is equal to 1. C times 1 is c, minus 1 times 7 is 7. I don't know if I should write everyone the other way also so you can see it, or you could have c minus 7 times x minus 6. And the same goes here. We have a multiplied by y minus 4 as a term, minus b times y minus 4 as a term. Your common binomial factor is y minus 4. You're factoring it out, undoing that distributive property, and you'll divide each of the terms by y minus 4 to figure out what goes in parentheses. Y minus 4 divided by itself is 1. 1 times a is a, minus y minus 4 divided by itself is 1, and 1 times b is b. So y minus 4 times a minus b, or a negative 4 multiplied by y, negative 4. All right, let's see what we have next. All right, sometimes a binomial factor must be rewritten before a common binomial factor can be found. So in this case below, we're going to have to rewrite the binomial factor before we can factor out the common binomial factor. So let's just look at this a little bit closer. Our first term is a multiplied by x minus b. But notice the x is positive in this first term and the 2 is negative. And if you look here, notice the 2 is positive and the x is negative. So what I'm going to do on this side is I am going to factor a negative 1 out of here. And by doing that, 2 divided by negative 1, it will make this a negative 2, and negative x divided by negative 1, it'll make that a positive x. Now let me just drop down my a parenthesis x minus 2. Positive b divided by negative 1. Now we'll have a minus b out there instead. But now notice negative 2 plus x is the same as writing x minus 2. So now I have a common factor that I can factor out. So now I can just go ahead and do what I've been doing on the previous ones. I can see that my common factor is x minus 2, so I will factor it out. And when I divide each of these sides by x minus 2, my missing factor is a minus b. Make sure you have parentheses around both of the binomials, or you could write a minus b multiplied by x minus 2. So we're going to do a few problems like this now where you need to rewrite or factor out a negative 1 on one of the binomials in order to be able to factor out a common binomial. So look at f. Notice we have b times a minus 7, and the next one we have negative 3 times 7 minus a. So we're going to factor a negative 1 out of here. Okay, so this is going to turn this into a plus 3. It's going to make my 7 negative. It will make my a positive. So then I can rewrite this as a minus 7. So then it'll look the same as my first term. Okay, so now we're in good shape. We have b times a minus 7 and 3 times a minus 7. So now I'll factor out my common factor a minus 7. So now to find my missing factor, I will divide this by a minus 7 and this by a minus 7, and you can see I am left with b plus 3. So a minus 7 times b plus 3, or b plus 3 times a minus 7. Right? We have one more of these. We have x times a minus 2b minus y times 2b minus a. So we have an a minus 2b and a 2b minus a. So once again, I will just factor out a negative 1 here. Negative y divided by negative 1, that will make that a positive y. It will make my 2b a negative 2b. It will turn my a positive. And then to make it look like my first term, I can write this as a minus 2b. And over here I have x, a minus 2b as well. And now we have x times a minus 2b and y times a minus 2b. I'll factor out my common factor a minus 2b. And to figure out what goes in parentheses, I'll divide this by a minus 2b. And this by a minus 2b. And I'll be left with x plus y. So we have a minus 2b multiplied by x plus y, or x plus y multiplied by a minus 2b. All right, let's take it a step farther. When your polynomial has 4 terms, we are going to use a process called factoring by grouping. Okay, and so there's a couple steps here, and I don't know if I should just read them to you. Maybe I should just go ahead and move to the first example and show you how we're going to do those. Now, at the bottom of page 174 and the top of page 175, there are a couple examples that are done for you. I kind of wish I just would have left those ones empty and worked those problems with you. So I'm going to go ahead and just jump to the problems at the bottom of page 175, but know that I'm going to be following the procedure for factoring by grouping that's found at the top of page 174. Okay, and this is what we're going to do. So on page 175a, so notice we have 4 terms here in this polynomial, and when you factor by grouping, what you're going to do is you're going to group the first 2, and you're going to go ahead and factor that as a binomial. So recall from 3.1, we're looking for a greatest common factor. And so it looks like, and when you're factoring a variable term, remember the GCF is going to be whatever the smaller exponent is. That's all they can have in common. And notice the 4x squared doesn't have a y, so a y can't be part of the GCF. So it looks like they have in common x squared. So I'm going to factor out an x squared. So I'll divide this by x squared and this by x squared. So I'll be left with y plus 4. And then I'm going to do the same thing on the other side. I'm going to factor the binomial 3y plus 12. So it looks like the common factor there is a positive 3. So I'm going to factor out a positive 3. So I'm going to divide this by positive 3 and this by positive 3. 3 divided by 3 is y. 12 divided by 3 is 4. And now look at what we have here. We have what looks like what we had in the previous problems we just did. Notice we have our first term is x squared times y plus 4, and our second term is 3 times y plus 4. So each of those terms has a common binomial factor that we can now factor out of there. So we'll factor out a y plus 4, and then to figure out what goes in parentheses, we'll divide each of those sides by y plus 4. And you'll be left with x squared plus 3. Now recall in Unit 2 that if we are multiplying 2 binomials together, we could use FOIL, first, outer, inner, last, and distributing. And if you did this here, you would end up with what you started with at the beginning if you wanted to check your answer. So our answer is y plus 4 times x squared plus 3. Or, of course, you could write x squared plus 3 multiplied by y plus 4. And that is a plus sign right there. All right, so let's practice factoring by grouping. And sometimes you have to change your signs on these, so it can be kind of tricky. And I mentioned that sometimes it's necessary to factor out the opposite of the GCF. So you just kind of have to watch things a little bit. So let's see what we have on this one. Looking here, the GCF of 10 and 15 is 5. We can factor out an x and a y. So the GCF of these first two terms is 5xy. I'm going to divide this by 5xy and this by 5xy. I'm left with 2y minus 3. We have a 6y and a negative 9. I am going to factor out a positive 3. Divide by 3, divide by 3. 6y divided by 3 is 2y. Negative 9 divided by 3 is negative 3. So we have 5xy times 2 minus 3 and 3 times 2y minus 3. They have a common binomial factor of 2y minus 3. I factor that out, and then I'm going to divide each of these terms by what I factored out. And so my other factor will be 5xy plus 3. And you could also write that the other way around, 5xy plus 3 multiplied by 2y minus 3. Make sure you have parentheses around both of the binomials. All right, we have 4 more to do before the U tries. So I will do those 4 with you. xy minus 5y minus 2x plus 10. This one might be a little trickier with our signs. So here, notice we can factor out a y. Divide by y, divide by y. I'm left with x minus 5. Now notice on this side, when you factor something out, in parentheses you're going to want your x to be positive. And in order, because you have a negative 2x there, which means in order for your x to be positive, you're going to have to factor out a negative 2. Not a positive 2, but a negative 2. So you're going to divide each of these by a negative 2. Negative 2x divided by negative 2 will give you a positive x, and positive 10 divided by negative 2 will give you a negative 5. If you would have factored out a positive 2, then you would have had a positive 5 instead of a negative 5. Okay? So we have y times x minus 5 multiplied by, or y times x minus 5 minus 2 times x minus 5. Now you can see we have a common binomial factor of x minus 5, which I'm factoring out. Divide each of your terms by your common binomial factor. And your missing factor is y minus 2. So x minus 5 times y minus 2, or y minus 2 times x minus 5. All right, D. Looks we can factor an x out of there. Divide by x, we get x minus 3. You want your x to be positive, so it looks like we're okay here. What can we factor out of there? It looks like we can take a positive 4a out of there. So if I divide this by 4a, I'll get x. And if I divide this by 4a, I'll get negative 3. That works out nicely. So I have x times x minus 3 and 4a times x minus 3. We have a common binomial factor, x minus 3. I'm going to divide by x minus 3. I'll get an x plus divide by x minus 3. And I get a positive 4a. So x minus 3 multiplied by x plus 4a, or x plus 4a multiplied by x minus 3. 2 more. And just recall, we use factoring by grouping when our polynomial has 4 terms in it. Okay? Alright, here 21x squared plus 6xy. It looks like we can take a 3x out of there. And so I will divide each of those by 3x. 21x squared divided by 3x is 7x plus 2y. Now once again in parentheses here, notice both of these terms here are negative. And you want them both to be positive inside parentheses, which means you're going to have to divide them each by a negative. So you want to factor out a negative GCF. And it looks like that would be a negative 7. So you want to put a negative 7 here. You're factoring out a negative 7. Negative 49x divided by negative 7 is positive 7x. Negative 14y divided by negative 7 is positive 2y. And good. 3x times 7x plus 2y and negative 7 times 7x plus 2y. Factor out your common binomial factor, 7x plus 2y times, divide each of these by 7x plus 2y because we factored out the GCF, undoing multiplication. Our missing factor is 3x minus 7, or the other way around. And our final problem in this section that we'll do together, looks like I can take an a out of there. I get 2y minus a. Now, this one could be a little tricky because you'll notice that negative 3a is negative and 6y is positive, but you want, in parentheses, you want the y part of your answer to be positive, and you want the a part to be negative. You see what I'm saying? So we really just need to take a positive 3 out of here. Divide by positive 3, divide by positive 3. That will give you a negative a and a positive 2y, which is the same as saying 2y minus a, right? So we have 2 times 2y minus a and 3 times 2y minus a. Our common binomial factor is 2y minus a, which I'm pulling out. Divide by 2y minus a. Divide by 2y minus a. And your missing factor is a plus 3. So 2y minus a times a plus 3, or you could write a plus 3 times 2y minus a. Ready. I hope I did a well enough job explaining this to you. Alrighty.